Welcome back, 5th graders. We are now in the share out, discuss, and analyze step of our task. And remember that our task today that we're talking about is in decimal operations, multiplication and division, and we are talking about task 8, ribbon cutting. So we're going to be discussing some possible solutions to solve this task. So remember, you had a length of ribbon and you were cutting it to make medals for the school-wide relay race. There are a total of 30 units of ribbon. How many ribbons can be made if each member's ribbon is 1 25/100ths of a unit long? So you first need to be thinking about what kind of mathematics that you can do. You might also go back and think about what you used when you did Meter Reader 2 with Miss Johnson, some of those strategies. And I know that in Meter Reader 2, you used some hundredths grids. And in Meter Reader 2, you were using totals of hundredths grids, 5, and you were dividing them into 25/100ths, so on and so forth. But in thinking about today's problem, I'm using 30 units of ribbon. So I'm not sure how efficient it would be to think about using 30 hundredths grids. We could do that, but a more efficient way would be thinking about solving this problem mathematically. So you know that you are trying to find out how many cuts of this size you can get for 30 units of ribbon. So let's think about what kind of math that we're going to be doing. We're starting out with the total units. We know that we're going to be grouping it in the size of 1 25/100ths. Now when I'm working with decimals, it kind of helps me to think about money, but you know if you have decimal numbers in this number, you need to make this number equivalent, so I would put my point and my decimal numbers right there. So I'm dividing the 30 units of ribbon into cuts that are 1 25 units long. It helps me to think about this. Actually, although you know in your mind that it's a division problem, a lot of us think about it as a multiplication problem. Why does that work, you think? Well, it works because multiplication and division are inverse, that means opposite operations, and because we know the amount in each group. Repeated addition could be used to do the multiplication, and we could think about it as 1 25/100ths times what is going to equal 30. So if we do that, let's think about an efficient method here. One of my students said, I know that 125 and 125 is 250. And I know that 250 and 250 is the whole number 5, or 5 and no 100ths. So if it takes 4 pieces of ribbon, 4 cuts, and I get 5 pieces, then how can I extend this and think about how many pieces I'm going to get out of all 30? Okay? So for 5 pieces, we made how many cuts? 1, 2, 3, 4 cuts to get us to 5 units. Okay, and so now we know that there's a total of 30. So now I'm thinking 5 times what is going to equal 30? And that would be 6. Okay. Now I'm thinking for each one of those groups of 6, I'm going to have 4 increments of 1 25/100ths. And 6 times 4 then would be 24. So it's going to take me those cuts, and I'm going to end up with 24 ribbons, and each one of those ribbons is cut in 1 25/100ths. So before we move on to B, let's go ahead and talk about this one and make sure that you have your head wrapped around what happened. Why did we multiply 4 times 6? Well, we counted that there were 4 125s in 5. And then we knew that 5 times 6 would be 30. So we decomposed the 30 into 6 groups and found how many 125s were in each of the 6 groups. And we could think about it as either a division or a multiplication problem. So let's go on to our next one where we're cutting the ribbon in 75 units long. Okay, so in doing it and thinking about it mathematically, my students said that they knew that 75 and 75, like 75 cents and 75 cents, if you think about money, is 150. So another 75 and 75 would be another 150, and together that would be 3, okay? So our equation here is 30 divided by 75 hundredths, or we could think about it as 75 hundredths times what is going to give us 30. And if we make it equivalent, we'll put the decimal point and the zeros there. So I'm thinking now, if I have 4 of these and they make 3, how many times is that going to take to make 30? There's 4, and 3 times 10 is 30, so that means I'm going to have to take the 4 times the 10, and that's going to give me an answer of 40 pieces of ribbon. So let's think about each one is 25 hundredths. You know that if we're thinking about 25 hundredths as quarters in money, that it takes 4 of them to make 1 unit. So if I have 30 units, I'm going to have to be thinking about 30 units, and I'm going to get 4 in each one. And then that's going to give me the answer of 120. So in this problem, our expression would be 30 divided by 25. Or we could think about it as 25 hundredths times what is going to give us 30. And our answer here would be 120, because we know that 4 times 30 is 120. So now let's look at our next pattern. This is a really tiny piece. This is only 5 hundredths of a unit long. So how many of these units is it going to take to make 1 whole? That would be like saying, on these hundredths grids, if I'm only coloring in 5 of them, how many of these is it going to take to make the whole thing? So that would be one group. 1, 2, 3, 4, 5. We could actually color them out. But you're thinking about 5 times what is going to give you 1 whole. Or 5 times what, if the decimal weren't there, would be 100. And you know then that it's going to be 20. So there are 20 ribbons in 1 unit. But we don't have 1 unit, we have 30 units. So that means for every unit I have 20. So now it would be like 30 times saying 20, 20, 20, 20, 20. So if I do that, I'm thinking, let me represent this here for you. We said that 0.05 times 20 is going to equal 1 whole unit. But our problem is 30 divided by 5 100ths. how many of these 100ths are going to be in 30? Well, if there are 20 in 1 unit and we have 30 units, we're going to do 20 by the 30 units, and that's going to give us 600. So our answer is, if we cut it in these teeny tiny pieces, we're going to be able to have 600 pieces of ribbon. So we went from 24 to 40 to 120 to 600. So the smaller the cuts that we make, the more pieces of ribbon that we can get. So what about if it's 50 units long? I'm thinking about what I know about 0.5, and I know that that is half. Okay? So I'm thinking about, I know that it's going to take 2 of these to make 1 whole unit. 1 whole. So our expression is 30 divided by 51/100ths, or 5/10, or 51/100ths, 5/10 times what is going to equal 30. Well, if it takes 2 of them to make 1 whole, and I have 30 wholes, I'm going to be thinking about 30 times 2, and that's going to give me an answer of 60. So I know that I can make twice as many as the total units of ribbon I have, which is 30, and 30 times 2 is 60, so that way I would be having 60 ribbons. Now you could use your hundredths grid. It is not quite as efficient because you would have to have a larger number, but you could do it on a smaller scale and think about how many parts would you have in 1 whole, just like we did with this one, and then apply it to what we're doing. So now let's go look at our true and false statements. Each result is greater than the 30 units of ribbon and the length of each ribbon made. Okay? So is 24 greater than 30? No, it's not. So I was only able, when I used the 1 and 25/100ths, we were only able to make 24 ribbons. So it's more than 30 the smaller that we got, but was it every time? No. So is statement B true? No, statement B is not true. Okay, now let's look at B. The number of ribbons created when each ribbon was 5/10ths of a unit, 5/100ths of a unit long, is half as much as the total units of ribbon. Is 5/100ths half? No. Half would be 5/10ths or 50/100ths. So that would be, no, that is not true. When we get to C, it says, creating ribbons that are 10 100 unit long would make 10 times as many ribbons as the total available. So would part C be true? Are we going to be able to make 10 from every 1 unit in 30? Yes, so that one is true. Creating ribbons that are 2 100 unit long would make 50 times as many ribbons as the total units available. Okay. Well, we first need to figure out what that is. If there are 30 units available and I want to make it 50 times more, how much would that be? Let's use what we know about multiplying by multiples of 10. I know that 3 times 5 is 15, and I have 2 multiples of 10. So that would be 1500. So now let's think about if we had 2 hundredths and we have 30 units. Would that be correct? Would that equal 1,500? Yes, it would. So that is true. So your task was to create one more true statement and explain why it would be true. One of my students created this statement. They said, if your ribbon length is more than 1, your answer will be less than 30. If your ribbon length is more than 1, your answer will be less than 30. Now let's go back to our calculations to see if that was correct. We only had one situation where our unit length was more than 1. It was 1 2500ths. And was our answer less than 30? It was 24. Yes, so that would be a true statement. For their false statement, they said, if your ribbon length is less than 1, your answer will be more than 30. So let's go back to our calculations. When we started cutting our ribbon in increments that were less than 1 whole, did we get more than 30? Yes. 2500ths is less than 1 whole, and that's more than 30. 5 100ths is less than 1 whole, and that's more than 30. 50 100ths, or 5/10ths of a unit, is less than 1 whole, and this is more than 30. So those are just some examples of 2 true and false statements that you might have come up with. This did require some mathematical thinking, so I hope that you were able to solve this task either using representations, or when we get into bigger numbers, thinking about breaking the bigger numbers into smaller increments using what we know to help us figure out what we don't know.